Everyone. I will first like to talk about the future of lithium-ion batteries, and then I'll introduce high-purity alumina. I guess who's setting the vision for lithium-ion batteries is probably Tesla, Elon Musk. And if you look at where the future of the batteries, this is the Tesla factory. This is the 4680 battery plant that Tesla is building. And if you follow the Tesla Battery Day, they have announced that they want to halve the cost of the battery production to below $100 per kilowatt hour. So they're probably running around $110 a kilowatt hour. They want to drop their production cost well below the $100. And the 4680 Tesla cell, which is what you saw in the video there, they believe is 5 times more energy and 6 times more power. Now, 4680, just if you want to know the technical term, is the size of the battery. So it's about 46 millimeters in diameter and 80 in height. They also announced that they want to have 3 terawatts per year of battery making capacities by 2030. So a terawatt is equivalent, 0.15 gigawatts is equivalent to 1 terawatt. So if you follow Tesla and the gigafactory in Berlin, it's equivalent to 20 gigafactories is what they're trying to achieve by 2030 in battery production, and also the costs being below $100 per kilowatt hour. They also announced that they want more silicon in the anodes. Now, silicon is 10 times the energy capacity of graphite, and we believe it will be up to 30% silicon in the anode side. Now, it's fair to say that most of the development in the lithium-ion battery has been on the cathode side. So you can see on this graph, it started as lithium iron phosphate cathode, and as you go across, you can see more nickel and cobalt in the cathode component. And so you've got lithium manganese oxide, lithium cobalt oxide, nickel manganese cobalt, etc., NMC. So more nickel and cobalt has been added to the cathode, and it increases the energy density of the battery. So a lot of the work has been done on the cathode side. It's also fair to say that much of the development is also now in the anode side. So if you look at a battery, you've got a cathode, the positive side, and the anode side. Now, when you charge the battery, the first thing that happens is all the lithium ions go from the cathode side to the anode side. And that's when the battery is being charged. Now, when you're ready to discharge the battery, all the lithium ions move back to the other side. But what's interesting is about 8% of the lithium stays on the graphite, and it becomes inactive. So before you get the battery, 8% of the lithium is already inactive to the performance of the battery. And this is called the first cycle lithium loss capacity. Who knows about the first cycle lithium loss capacity? Well, the industry has been trying to resolve this because what happens with that lithium, it forms a layer around the graphite particle, which is called the SEI layer, or solid electrolyte interface. And when it forms this layer, the lithium becomes inactive. And so the industry has been trying to resolve this problem so that they can increase the capacity of the batteries, but currently, they've been trying to coat the graphite particles with alumina, but it's rather thick in layers, quite inexpensive, and not commercial. So let's look on the molecular level what happens. This is a graphite particle. When you first charge it, the lithium ions go across, and it starts to form an SEI layer. Now, if you look at the performance of a battery on a chart, this is what the first cycle loss capacity looks like. The capacity drops, and then you've got the life of the battery. At 80% level, that's the life of the lithium-ion battery. Okay, so my question to you is that if you can resolve this first cycle loss capacity, can you see that the battery capacity is going to be 8% high before you get it, and also longer life. So this has been the challenge for the industry. One of the other things in the life of the battery is that the electrolyte is a lithium phosphate and fluoride. And during the performance of the battery, any moisture in the electrolyte forms hydrofluoric ions, and it breaks down the SEI layer. And as it breaks down the SEI layer, more lithium is absorbed, and so you see a degradation of lithium through the life of the battery. Okay, we've come up with a technology using our high-purity alumina to coat these graphite particles. So essentially, we have a very thin layer, and it stops the lithium from forming around the graphite particle or the SEI layer. Now, the layer of alumina that we form is at the nano size layer, so probably about 2 to 3 nanometers. Now, what's a nanometer? A nanometer is 1/1,000,000th of a millimeter. And so to give you a context, your red blood cell is probably about 10,000 nanometers. Now, we're dealing with layers that is 2 nanometers. Now, what's the beauty about our alumina layer? It allows the lithium ions to go through it, and so it doesn't stop the performance of the battery. And the other great thing about our alumina layer, we believe, is that it'll start absorbing the hydrofluoric ions. It absorbs the hydrofluoric ions and it converts it to an inert material. So the degradation of lithium going forward is minimized. So we look at the graph again and we say, if we can resolve this first cycle lithium loss, this is what the performance should look like. Very reduced first cycle loss, and the curve stretches out. At the 80% level, that's the life of the battery. So we expect an extension of life of the battery just from coating the graphite particle with alumina. We are well in our test work, and if you look under the microscope, very strong microscope, the right-hand side is what conventional people are doing. They're trying to coat particles. You can see how irregular, thick layers that are going on there. And on the left-hand side is a graphite particle we coated with our HPA and our technology, and you can see a very fine layer, very continuous layer around the graphite particle at about 2 nanometers. We're very excited about the technology, and we think that it's going to resolve the first cycle loss issue, a game changer for the lithium batteries going forward, and potentially increasing the density about 8% and maybe the life of 20 to 30% extra life. We have now announced a pre-feasibility study for a battery minerals coating plant in Germany. So we're using our HPA from Malaysia. We would coat battery materials with alumina. It's in the Saxony plant state of Germany, where a lot of the EVs and battery plants are being built. Okay, we also announced a joint venture or a collaboration agreement with Ferroglobe. It's one of the largest silicon producers in the world, and they want us to coat their silicon to go into the batteries. So I just want to talk about why silicon is such an important material. It has 10 times the capacity of graphite. Essentially, it has more sites where the lithium can come across and sit. But the problem is silicon, it expands about 300% in volume, and we don't think that you can get all silicon anodes, so graphite will always be there, and we think the proportion of silicon will be increased as you go through over the decades. So silicon is a very important development in the lithium-ion battery. Why are we focused in Europe? Essentially, Europe will be the big change in the lithium field. All driven by EU targets. So 2020, the EU wants to be 95 grams per kilometre. All car manufacturers need to average below 95 grams per kilometre. And if they don't average below that, they will get fined for every vehicle at 2,000 euros. So they don't have a choice. And you would have seen the UK have started to ban fossil fuel vehicles, for, I think, from 2030. So the push in Europe is very strong, and they want to be less reliant on raw materials coming from outside Europe, particularly Asia. So if you look at the chart of all the battery capacities that's been announced, you have companies like Northvolt, CATL, Samsung, etc., all building factories in Europe to supply this big push in EVs. So how does it relate to high purity alumina? Most of you would have heard of us. Our vision is to build a 4,500 tonne per annum high purity alumina plant. High purity alumina is used in lithium ion batteries as well as LEDs. And LEDs basically sweeping the world because it uses 1/6 the amount of electricity. And as I mentioned, high purity alumina is used in lithium batteries. Today is used in the separators. Today has been coated on the cathode side. Today has been coated on the graphite side. And people ask me, well, what happened to solid state batteries? Will alumina be used in solid state batteries? Actually, 2 to 3 times more alumina will be used in a solid state battery. Because essentially you take away the liquid electrolyte and you pack it with alumina. The forecast for high purity alumina is going to grow from 30,000 tonnes per annum to 270,000 tonnes per annum. There's a forecast shortage going forward, but the key part of our technology is our process. There's chemical companies today that make high purity alumina and they use aluminium metal as their feedstock. Very expensive feedstock. We have technology that bypasses that. So aluminium metal is very expensive because it comes from bauxite. They make smelter grade alumina. They sell it to the alumina refineries and then they go back to alumina. Doesn't make sense. So my question to you is that if you have technology that can bypass the aluminium metal stage, will you be disruptive and will you be the lowest cost producer? Essentially, our technology does that. We take the ore to the alumina in one single step. But we don't start with bauxite, we start with kaolin. Kaolin is a highly weathered material. Mother Nature has stripped out a lot of the impurities. The project is in Meckering. We've got about 250 years of mine life material. It's ready to go. We've got all the permits and so on. Now, the chemical plant will be in Malaysia. We've selected Johor in Malaysia, right on the tip, right across the road from Singapore, in a very large industrial park. A lot of foreign companies operate there. And the reason we picked Malaysia is essentially costs. 60% reduction in costs, labour, construction materials, and solvents and so on. That's what the plant looks like, pure German engineering from SMS Group out of Germany. We also recently got accredited as a green project. So how can a mining chemical company be a green project? Essentially, because we don't use aluminium metal, we are 49% less greenhouse gases to produce 1 tonne of HPA. And we use 41% less energy to produce that HPA. So we got a credit as a green project. And in a second, I'll talk to you about accessing the green bonds that we are looking at on debt. We have a 10-year offtake deal with Mitsubishi. They will buy all our products over 10 years. And on the construction side, we've engaged SMS Group. And essentially, they'll give us a fixed price lump sum guarantee. So they take all the risk on capital cost blowouts, delays, and process and quality. So they guarantee all that. The economics is very strong, up to $500 million NPV. It should generate around $76 million US free cash at its full rate. Very strong economics. And so the question is, how are we financing it? We have 190 million of the project financed with a German company called KfW, and that is at very low interest, long tenure loans. So that 170 million is about 14 years at probably 2.5% plus LIBOR. So very low interest, long tenure, and you can imagine the due diligence that we had to go through. We are accessing the green bond market. We're accessing 144 million US, of which 100 million will go to the project. Again, this is ongoing. But rather than wait for all the financing to come in place, the board has decided raise the money and start the construction process. The reason for that is it de-risks a greenfield site. So any site, you have always the risk of not getting to the site, permitting, environmental permits and so on. So we have achieved all that, and basically we started the construction process. We know the ground conditions. We build this very massive maintenance workshop that's part of the project so we can use during construction. We build the substation, and the reason for that now, we can safely say that we will have a running start when finance comes through, because we know the ground conditions, we know the contractors, we know all the environmental situations. So thank you for your time, and Altech is very placed to meet this new market. It is very similar to the lithium industry 12 years ago. So thank you very much.